Welcome to Chemistry at Hanamiga High School. I'm Brian Brown, and today we'll be looking at our first couple of sections of Chapter 1, which is our Introduction to Chemistry chapter. Now, the first section deals really with the scope of chemistry. So what is chemistry? What are we going to be doing this year? Well, first off, chemistry is the study of the composition of matter and the changes that matter undergoes. So it's having a better understanding of matter in the world around us and what its chemical and physical properties are and how that make it useful, useless, safe, dangerous, and so on. And when that matter undergoes changes, how and why does that occur? Now, matter is anything around us that has mass and volume. So matter really is anything around you that you can touch, that you can pick up, you can feel, and that has a mass and a volume to it. Now, volume is the amount of space an object occupies. So the more space it occupies, the bigger its volume is. And mass would be the amount of matter that the object contains. Now, don't confuse mass with the weight of a substance. 'Cause that's something we often talk about weighing something and then we mass it, but the weight of a substance really isn't the mass. Weight is how much the mass is affected by gravity. So it's really gravity's effect upon an object. Now, this is proportional to the mass. So the larger the mass is, the more gravity affects it. And that's really what you're measuring when you're measuring, how many pounds weight is something. That's looking at how gravity affects the mass. And it's proportional not just to the mass, but also to gravity. So unlike mass, which is constant no matter where you're at in the universe, weight changes. When I go from Earth, which has a larger gravity or force of gravity than on the moon to the moon, which is, I think, around 1/8, I'm going to weigh significantly less. I'm going to weigh about 1/8 of what I did on Earth, but my mass is the exact same. So please don't confuse the concept of mass and weight. We often talk about weighing things, but we're really, in chemistry, looking at weighing and finding the mass of an object. Now, one of the things about chemistry is traditionally chemistry has been broken into different types of chemistry or different branches of chemistry, really different areas of study. And often in college, you would have different branches within the chemistry department dealing with these different types of chemistry. First would be organic chemistry, which is the study of carbon containing chemicals. So chemicals that have carbon backbones to them, understanding how and why they behave in the way in which they do, and that's organic chemistry. In organic chemistry, all of the living material around us is made up of organic material. So that's looking at the study of carbon containing compounds. Inorganic chemistry would be the study of matter that does not contain organic chemicals. We look at some organic and some inorganic in times in chemistry, but when we're actually talking about chemicals, we're probably talking about inorganic chemical situations more often than organic chemical situations. Now, physical chemistry would be the area of chemistry that deals with the mechanism, the rate, the energy transfer that occurs when matter undergoes changes. So it's basically looking at understanding why, as matter undergoes different changes, the speed of reactions, the actual mechanism by which the atoms and the chemicals reacting actually interact with each other, and the energy changes of those things. That's typically physical chemistry. Analytical chemistry is the study that focuses on the composition of matter. So if I want to know if my drinking water is safe to drink, I would send it off to an analytical chemist for analysis, and they would give me a chemical breakdown of what's inside the water. And then finally, we have biochemistry, which is basically a blending of biology and chemistry where we look at the study of matter and processes of living organisms. So we look at the chemistry of how and why living organisms do what they do on a fundamental level. Now, at one time, these were considered, very different branches of chemistry, but in reality, most knowledge in most types of chemistry blurs the line between each of these, but you should have a fundamental understanding of some of the basic types of chemistry that exist. And I can remember, being introduced to a college professor, and he said, I'm a professor of analytical chemistry or whatever at this university. And realistically, like I said, the boundaries are not firm, and chemists often work in more than one area at a time. And for the most part, if I'm asking you about this in a test type situation, expect to see it as a matching type situation. So you can pitch and choose and use process of elimination to try and figure out what is what. Now, when you are studying chemicals in a chemistry situation, a biology situation, or physics, or any type of science situation, when you're doing research, there's two fundamental types of research. So there's different types of chemistry. There's also different types of research that can occur. One would be pure research. In pure research, what you're doing is trying to find out for the sake of knowing. So it's a pursuit of chemical knowledge for its own sake. You're studying just to understand the situation. You're not really studying to try and do something, although it may get used afterwards for something else. But really, I have a question. I want to know why it's happening. Now, if on the other hand, I have a chemical problem that I'm trying to solve, and I've got a product that I'm trying to make, what I'm looking at is applied chemistry. I'm studying and researching to direct it towards the actual manufacture of some type of physical product. So I've got some kind of practical goal or application in mind. So I'm studying it to try and use it to solve some type of chemical problem. That would be applied research. So most research that happens in universities is going to fall into one of these two categories. Sometimes it's pure, sometimes it's applied. If business is involved, it's probably going to be applied research because they're trying to understand something to harness it to use and make some kind of product. Now, examples of these two situations. Alexander Fleming is a famous scientist. And in a pure research situation, he was trying to understand why some mold that had formed on an old petri dish was killing the bacteria that was growing in the dish. So he had some petri dishes, and for some bizarre reason, there was something that was killing the bacteria that he was trying to grow inside the petri dish. He wanted to know why. What was it that was happening? Well, that's an example of pure research. Now, applied research would be a situation where 12 years later, other scientists were looking specifically at this chemical that he found to try and isolate it and manufacture it so that they could use it to kill bacteria in humans and other animals. So now what we're doing is not just knowing to understand, but they were really trying to find out what this substance was and could it be used to treat bacterial infections in people. And they developed the chemical penicillin. So similar ideas, we're talking about really penicillin in both cases, but in one case we're looking at pure research, and in another case we're looking at applied research to come up with an actual application. Now, technology is something we talk about from time to time, and technology is important in chemistry as well. Technology is the means by which society provides its members with those things it needs and desires. So when we take pure or applied research and we come up with a manufactured product, now we're looking at a use of technology. It's a practical use of scientific information. So you're taking that research and you're translating it into some sort of useful process or application or product. So why study chemistry this year? Well, actually, one of the reasons you're studying chemistry, and this is the biggest reason, which is not on my notes here, is probably because you were told this is next. You've taken a level of biology, and at Hananiga, what comes next, if you're planning on going to college, is chemistry. So honestly, most of you are here for that reason, and honestly, for that reason alone. But what are some other reasons you might want to study chemistry? Well, the world around us is made up of chemicals and chemicals interacting. So having a better understanding of chemistry will give you a much better awareness of the world around you and potentially in some situations save your life. It also might prepare you for a career. Maybe you're going into a math or science field, and this is laying the groundwork for some of the things that you're going to pursue at a higher level. And then finally, just to become informed. We see things on the news, in the newspaper, we're told things all of the time. And if we have a better understanding of the chemical nature of what's around us, we're going to have a better understanding of what we're being told. And maybe we may understand that doesn't make any sense. Maybe this isn't right. Or maybe we have a better understanding of an application or the safety or hazard in a certain thing that we're seeing or hearing. So another reason to study is really just to have a better understanding so you're a better, more informed citizen. And that ends our first set of notes in chemistry.